Hello everyone, my name is Mitesh Joshi from Team Phenomath, and we are going to brief our research on techno-economic analysis of carbon capture and storage with my team member Vrushti, Vikram, Sneha and Niyati, and mentor AICHE ma'am, woman of researcher. We have covered method and technology related to carbon capture and its storage, its economical analysis and knowledge gap associated with it. After industrial revolution and rise in population, human influence on environmental changes has been increased. Due to our currently adopted practice of energy generation, manufacturing, transportation and waste management, one such change is rapid increase of carbon dioxide concentration in atmosphere faster than environmental recycling rate. And from Tyndall experiment of 1859, it is clear that gases like carbon dioxide, water vapor and methane causes rise in earth temperature by absorbing earth's reflected radiation in atmosphere. By global warming, water, food and resource scarcity by increase in variation of average climatic condition and rise of water level has become serious global concern. However, by understanding environmental carbon cycle, we know that we can fix carbon in geological formation, ocean and mineral other than reducing and reutilizing the carbon. For fixing, we first need to capture pure stream of carbon, commonly carbon dioxide.
Discussing of the critical sources of carbon dioxide emission, some of the key contributors are large-scale manufacturing and processing driven by industrialization in developing nations, release millions of tons of CO2 into the atmosphere annually. This surge is particularly evident in the combustion of fossil fuels like coal, natural gas and oil. Within the fossil fuel category, coal combustion stands out as a primary culprit. Coal emits more CO2 than other fossil fuels due to its lower energy content compared to oil and natural gas. Examining global energy consumption trend in 2018, natural gas contributed one-third with a notable rise from 1.94% in 1960 to 28.05% in 2018. Talking of transportation sector, which generates around 24% of global CO2 emissions, the focus turns to vehicles, ranging from small cars to large ships and airplanes. Powered by internal combustion engines, fueled by gasoline and diesel, these machines contribute to CO2 emissions. The inefficiency of these engines compound the pollution issues. Shifting to industrial processes, 23% of carbon emission in 2021 originated from the combustion of fossil fuels during manufacturing and specific chemical reactions. Industries like cement, oil, chemical and metal production significantly contribute to CO2 emissions. Notably, the cement industry plays a crucial role due to the chemical processes involved in production, including the calcination of limestone, fossil fuel combustion and transportation of raw material. Beyond industry, the production of heat and electricity claims responsibility for over 40% of the world energy-related CO2 emissions. This fossil fuel dependency underscores the urgency to explore cleaner energy sources. Agricultural practices introduce a variety of methods that increase CO2 emissions, including mismanagement of livestock manure, rice cultivation, burning crops residue. Additionally, the use of fossil fuel in agriculture for tasks such as transportation, irrigation contributes to CO2 emissions. In conclusion, the sources of CO2 emission are diverse. Addressing this global challenge requires a collective commitment to sustainable practices, renewable energy and innovative technologies.
Now, effect of CO2 emission consists major issues raised in global level. Increased emission of CO2 contribute to global warming, leading to climate change, rising sea levels and disturbance to ecosystems, impacting both environment as well as human beings. The current global average concentration of CO2 in the atmosphere is approximately 421 ppm as of May 2022, representing a 50% increase due to industrial revolution. One of the major problems faced by the world is ocean acidification. As carbon dioxide is absorbed by ocean, it reacts with seawater to form carbonic acid, which lowers the pH of ocean water. This process has significant consequences for marine life and entire ecosystem. Acidification makes it more difficult for organisms to build and maintain their shells. Then other one is CO2 fertilization. CO2 fertilization refers to the positive effect as plants use sunlight, water and CO2 to produce energy through photosynthesis. An increase in CO2 concentration can lead to increased rate of photosynthesis and growth. This phenomena has been observed in crops such as wheat, rice and soybean, etc. It also has potential drawback like increase in CO2 level can lead to decrease in nutritional quality in crop such as lower protein content in wheat and negative impact on agriculture and food security in long term.
Now, we have also studied about various important technologies for carbon capture and storage like adsorption, amine-based scrubbing, membrane separation and cryogenic separation. Each method has its own advantages and suitability depending on the specific industrial application. Currently, carbon dioxide capture by amine-based chemical absorption is the most popular technology to reduce CO2 emissions. It involves absorbing CO2 from industrial gases using a liquid solution containing amines. In this process, the flue gas containing CO2 passes through a contactor where it comes into contact with the amine solution. the CO2 reacts with the amine, forming a compound that can be separated from the rest of the gas. Afterwards, the CO2-rich amine solution is heated to release the captured CO2, allowing the amine to be reused in the scrubbing process. Since there is a regeneration stage, this process consumes a lot of energy. This process is commonly used in natural gas processing industries. Now, moving on to the next method for carbon dioxide capture, that is membrane separation. It involves using a semi-permeable membrane to selectively separate CO2 from flue gas based on the differences in their sizes or solubilities. These membranes allow CO2 molecule to pass through more easily than other gases, hence allowing separation. The process is often less energy intensive than other methods such as amine scrubbing, but it may be limited by the size of operation and the need for specialized membranes designed to trap CO2 efficiently.
Chemical adsorption and absorption are now thought to be the most suitable ones for post-combustion power plants. So, in this section, we will talk about CO2 adsorption. Potential strategies for removing carbon dioxide from high-pressure fuel gas streams include pressure swing adsorption and temperature swing adsorption. Although zeolite are viable candidate solvents for applications in these processes, the system would be even more energy efficient if the solvents were operational at moderate or high temperatures. So, the next technology is porous material. Because of possible applications such as carbon capture and storage and the purification of clean-burning natural gas, the development of novel macroporous material for adsorption separation processes is a rapidly emerging topic. New metal organic frameworks and other porous coordination polymers in particular are being created at a quick and increasing rate. MOFs, zeolites, POPs, porous carbons, and mesoporous materials are the most commonly used porous adsorbents in CO2 capture and conversions. Next technology is cryogenic separation. Cryogenic CO2 removal technologies absorb CO2 in liquid form and making it relatively simple to pump underground for storage. This novel cryogenic CO2 removal technology was developed and tested in demonstration plant and is soon to be implemented in commercial field application.
This captured carbon then can be stored in geological formation, ocean bed and mineral to prevent the rising concentration of carbon dioxide in atmosphere. Identification of storage site, storage capacity, efficiency against leakage to atmosphere, storage mechanism and possible risk are some of the important parameters related to storage site. Further in this research, we have covered economical analysis of individual and combined processes involved in carbon capture and storage. Investing in carbon capture and storage present both challenges and opportunities, with economical and knowledge gap as major challenge and to achieve net zero carbon and better planet as opportunities. Thank you.